Look at my video, man. All right, everybody. Thank you again for coming and tuning in to Mentoring Mighty Minds video tutorials. I really hope that they're helping you out in your studies. I know some of us may be algebra students, some of us may be eighth grade students, but I try to make a measure of content for everybody. If you have any comments, questions, and you can't leave them at the bottom, you can always feel free to email me. All of my information, contact information is down at the bottom. I just want to thank you guys for subscribing, following along, using these videos to help you out in your learning. That's my main focus. That's why I started doing it. So I'm glad that you all are enjoying it. Okay, today I want to talk about geometric transformations. Geometric transformations. All right. And hopefully you've already studied this in class. You have a little bit of information on it already. But just to make it simple, geometry is shapes, transformations means to change. So basically, we're going to talk about how your shapes change. Okay. Very nice and simple. There are four ways that your shapes can change, or that you'll be discussing in this unit, I should say. And that's going to be translations. Then you have reflections. Okay. You can't forget about rotations. We'll start it about there. And then last but not least, you have probably my favorite, dilations. Okay. Now, I'm going to just draw a line down here to kind of separate our information here. Okay, because I'm going to have the words over here, but I'm going to have kind of examples or how they should look over here. So when you see translations, all right, the easiest way to remember that, I know we don't use the word translate very often, but we do use slide. And if you notice, there's a SL in the word slide. Okay. For reflections, we don't use that word very often unless you're in the mirror, but you know, in the mirror, all of your images flip over. Rotations, we have two T's. However, they don't start the word that you need turn. And then dilations have no letters to emphasis on, but what you can remember is just like if you were to wear glasses, that means to get bigger or smaller or get smaller. People with glasses know what I'm talking about when you have to go to the eye doctor and they spray that puffy stuff in your eyes. You know what I'm talking about out there. People who wear glasses, you know what I'm talking about. All right, and so we are going to just discuss, like I said, each one of these: translation, reflection, rotation, and dilation, and try to just get an understanding of what should we expect when you translate. Okay, you have to remember when you're translating, all you're going to see as far as your algebraic expression is to add or subtract. Okay, that's all you're going to see. And I'm going to jump down to dilations because that one has an algebraic expression of just multiplying. Okay, multiply. That's it. That's all you're going to see is multiply. All right. When you get to reflection and rotation, you just have to remember the rules. Okay. And I'll give you the rules in just a moment. Okay. You just have to remember the rules. Okay. And so when it's time to look at the algebraic expression, I'm going to keep the blue so you know that it's all the same thing. So let's start with translation. Like I said, it's adding and subtracting. So if they give you the verbiage and say we're going to translate an image 7 units to the left, okay, and 4 units up, you need to think about your X and Y axis. Okay. The X can only go left to right. So if we know the X can go left to right and it's 7 units left, that means the X is minus 7. Okay. And 4 units up, well, the only axis that goes up is the Y axis. So if it's 4 units up, that's going to be Y plus 4. And there you have an algebraic expression that resembles what we talked about. All right, let's try one more. If I was to say, how about 3 units right? And then 2 units down. All right, go ahead, pause the video, see if you can do this one on your own. All right, that should have been enough time here. We're gonna just say 3 units right. We know X and Y, X always goes left to right. So when it's right, you're adding. So that's X plus 3. And then 2 units down is the Y. And when you go down, you take away. So there's your algebraic expression. Okay. And that's pretty much it for translations. Now I will give you a heads up. You won't always have it, the X and then the Y. Sometimes it may say 4 units up, 7 units left. That's fine. The order doesn't matter. You know the direction. So as long as you know the direction, you're good to go. Reflection, like I said, reflections have rules, rotations have rules. So I'm gonna go back to the last algebraic expression to try to keep it similar so you can see the differences and the similarities back to back. When you talk about dilations, it's multiply. Okay, it's multiply. It's only multiply. So if I was to say scale factor is the word that you would use in your descriptions, just like translations. We use the words units left, units right, units up, units down. They would use scale factor. So an image is dilated with the scale factor. Scale factor of 2. All right, a scale factor of 2. So what that means is we have to get bigger by 2. So you'll see your original point. All right, and it's gonna always have this arrow right here. And then the algebraic expression would be I'm multiplying by 2. 2 times X, 2 times my Y. Simple. That's it. That's your algebraic expression for a scale factor of 2. And that means get bigger. Okay, that means get bigger. But what happens if we want to get smaller? Well, you'll have a scale factor of a number less than 1. Scale factor of, let's say, 3/4. That's smaller. So then we'd have
one more time, teachers, faculty, staff, and students. Welcome to this wonderful Wednesday.
It's translated teachers, by image.
Teachers, and then you have your scale factor of location, 3/4. Be sure to make your way there at this time. Again, thank you in advance for a wonderful day.
All right. And so there you have just the different ways of introducing your scale factors. All right. If it's bigger than 1, it's going to be getting bigger. If it's less than 1, of course, your image is going to be getting smaller. All right. And so those are the ones for when you have a scale factor. All right. Now we have, or a algebraic expression, I should say. And now we're going to get into the ones that have rules that you just kind of have to memorize. The good news is reflection rule is not hard at all. The rule is simply this. If you flip over the x-axis, then you need to change your y. Okay. And what that means is I'm going to start off with x comma y. Okay, I'm going to see some type of transformation. My X is going to stay the same, but then my Y changes. See how the Y changed? Now the Y is negated. Okay, and on the other hand, if you flip over the Y-axis, then you change your X. And what that looks like is X comma Y. Always start with an X comma Y. There's your arrow. And now my X is flipped. See how my X is negative? All right, so that's why I say it's pretty simple for those, because it's just a rule that you need to remember. All right, now rotations. Rotations are pretty simple as well, and it's because it's just a pattern you have to remember. And the easiest way to remember it is to write it down in this manner. You have to remember your coordinates. On a coordinate plane, you have 4 boxes, and it's 90 degrees, 1 turn. 180 degrees is 2 turns. 270 degrees is 3 turns. 360 degrees is back at original, but that's 4 turns. And there are factors of 90. Okay, if you were to look at a coordinate order, what do you call it? Coordinate plane. Okay, this section here is 90 degrees, is it not? So that's why that's 1 turn. This section here is another 90. That's why together they make 180, 2 turns. And so you just have to put that into perspective that each turn is 90 degrees because we are talking about a coordinate plane. So if each section is 90 degrees, that means you're going to have 90, 90, 180, 270, and 270. Now you may say, why is it 2 of each? Because you can go left or to the right. If you go to the right, it's clockwise. If you go to the left, it's counterclockwise. Okay. And if you're wondering why is it 180, it's because if I go to the right twice, I'm upside down. Just like if I were to go to the left twice, I'm still upside down. So it doesn't matter. It's only one way you can go for 180, or one rule you can have, I should say. So now this is how you remember it. For each turn, your Y's are going to be in front now. So that means I have Y, comma, X, Y, comma, X, Y, comma, X, and Y, comma, X. Now you may say, why did you skip 180? Because this is the only one that stays X, comma, Y. However, both of them are negative. All right, now how do you know which ones are negative up here? Well, in the pair X and Y, X comes first. So X gets the negative first, and then Y. And there you have your rules. If you remember that, you can do any rotation you need to. If I say a 270 degree counterclockwise rotation, then my point should change. The Y should come first, and the X value should be negated. If I say a 90 degree counterclockwise rotation, then my X and Y are going to flip, but my Y is going to be negated this time. So if you remember this, or can just spit this information out, then you'll get it every time. I really want to thank you guys for watching. I hope you enjoyed your notes. Take a nice little picture of that. Hopefully you got it all. But this is your geometric transformations video.